Okay, so we're going to look at permutations when the objects are alike, and we've been given two questions here. Okay, how many distinct words can be made from the word Ottawa? Now, by distinct words, we don't mean they have to be real words. Just how many different ways can this be rearranged so that the order of the letters aren't the same? Okay, so let's kind of think of it again. We have 1, 2, 3, 4, 5, 6. So we have 6 spots. Okay, 1, 2, 3, 4, 5, 6. Okay. Normally what this would mean is you can just kind of set up a factorial. Say we put O first. Well, there's 6 options, and then there's 5, 4, 3, 2, 1, right? Which is essentially 6 factorial, right? And that tells you how many options there are. The only problem is we have pairings, 2 T's and 2 A's. And we don't want to double count. And what we mean by that is think of it like this. Let's say we were building, we're starting with the letter T. Instead we went T, and then we put O, A, oops, sorry, that's not what I want to do. O, T, A, W, A, okay? Well, let's say we reverse the order of these 2 T's. Well, that becomes T, O, T, A, W, A. And this was T1, this was T2. Now this is T2 and this is T1. Now, besides those subscripts 1 and 2, it's technically the exact same thing, right? So even though we have moved the order of these 2 T's, this doesn't really count because it's not distinctly different from the one above. Okay, so what we have to do from there, and if we ran out all the options you would see, essentially when you have a pairing, you're going to have to divide by the number of duplicates there are, factorial. So because there is a pair of T's, because there's 2 of them, we divide by 2 factorial. Okay, and because there's a pair of A's, so there's 2 of them, we divide by 2 factorial again. So we're going to multiply these 2 numbers on the bottom. And this is how we kind of set up our technique. And what this will be is divided by 2. I think it's going to be 90? Nope, 180 maybe. I really should put it into a calculator. Let's take a look. I don't know if I can do factorials. Oh, I can. Wonderful. 6 factorial is equal to, and then I'm going to be dividing by 2 factorial is 2, and 2 factorial is 2, so 2 times 2 is 4. Okay, so I'm going to divide by 4. Does that make sense? Yeah. 180. Woo! I can't believe I got that. All right, so there are 180 distinct different ways we could rearrange the letters in Ottawa. Okay, so our second example here, in the words Mike's Mathematics. Okay, so just imagine this is going to be another set. We're going to first need to count out how many options we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so there are 16 options, which means there are 16 factorial on top. There are 16 different words. But we do have a ton of double counting, okay? First of all, we have 1, 2, 3 M's, okay? So M's, there are 3 of them. We have 1, 2 I's. There are 2 I's. We have 1, 2 E's. I need another color. Orange. What else we have? We have 2 S's. S equals 2. Oh, we got a whole bunch more. Look at this. We got 2 A's. Okay, so A equals 2. And we've got, I think there's 2 T's. Nice. I need another, geez, I need another color here. Well, yellow, maybe, what haven't we, turquoise, maybe that'll show up. 2 T's. Okay, so T's equals 2. So that is a ton. Okay. So what really happens is that really limits their amount of options. 16 factorial is a huge number, but we're going to be dividing by 2 factorial times 2 factorial times 2 factorial times 2 times 2. And really what I wanted to show was the 3. The 3 is important because there are 3 M's. You get divided by 3 factorial, which is actually the value of 6 because it's 3 times 2, right? So that's really important there. So we have 1, 2, 3, 4, 5 of those, and then a 3 factorial. So we're dividing by 1, 2, 3, 4, 5, and then the 3 factorial. Okay? 16 factorial is a massive number. On the bottom, this is essentially going to be 2, so 4, 8, 16, 32, and then 32 times 6. That's going to be, I'm going to have to write it. So that's 12 and 192. So it's 16 factorial divide 192, I believe. Should probably check that. But let's take our calculator. So 16 factorial divided by 192. Oh my gosh, it is still a massive, massive number. Essentially what it's saying is it goes to 11 decimal places. So let's see if I can't squeeze this in here. Try my best to put this all together. So what that's saying is it's 1, 0. So it's 1 decimal place, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Oops, not 12. 11. I'll get that in a sec. So we're looking at, there's billions, trillions, 108 trillion options for that word. So it really escalates very quickly.